All right. So there's a few definitions at the top that are going to be kind of key for that IXL L.1 that you guys are going to do for homework. Now, there are two other definitions that you guys need to understand, and that's just if you have a column matrix, it's a single column. If you have a row matrix, it's a single row. Okay? And that's just something that'll pop up on the IXL. But other than that, a matrix is a rectangular array of numbers written within brackets. The order, that's the dimensions, you go number of row by number of columns. So if it's 3 rows this way, 2 columns that way, it's a 3 by 2 matrix. If it's 4 rows up and down, so 4 going this way, and then 6 columns going this way, it's a 4 by 6. Okay? And we'll go through how to name some of those as we go on. An entry, this is also called an element. It's a number that has 2 letters after it. So if you say this, they call them IJ here. The first number is your row number, and the second number is your column number. So if you were to see something that says, what element is A sub 12? That means first row, second column. If you were to see, what number is at...
Hey, sorry.
Yes.
College Jackson.
So if you were to see A sub 23, that's second row, third column. Right, so it's just, that tells you a location to go to do whatever it's asking you to do.
So it can be numbered, it's always numbered.
It's always numbers, yes. Because we always number our rows, we always number our columns. All right, a square matrix basically means number of rows is the same as number of columns, so 3 by 3, 4 by 4, 2 by 2, anything where this up and down numbers and side to side numbers are the same. And a zero matrix is a matrix where every single number in the matrix is a 0. Now we also have something called an identity matrix, and that's basically where you have a diagonal that goes from top left to bottom right. It's 1s, everything else is a 0. So questions on the definition side of the house. Now, when it comes to properties, we do a lot of the same things here that we've done with equations all over the place in just about every other class we've ever taken. So we are going to pretend that A, B, and C all represent some matrix somewhere. So the commutative property basically says you can change the order in addition and get the same answer. So whether I add this matrix plus this matrix or switch them and add them in the same order, I'm going to get the same answer. Okay? Associative means if you've got 3 and I want to add these 2 first, if I want to add AB first and then add C, or I want to add BC first and then add A, they still equal the same exact thing. Do you guys remember this? The associative property from way back when, the commutative property? They don't change. They're staying the same. Additive identity, that's where you add a 0. And if you add a 0 to anything, you still get what you started with, right? Just know that the 0 doesn't represent the number 0. It represents a matrix that's the same size as A. And then the additive inverse means if you add the opposite of the matrix you have, then you're going to end up with all the entries being 0. So we're going to start by actually practicing figuring out what the order is. Now remember, order is the dimensions. So, how many rows does this have? 1. How many columns does this have? 2. So a 1 by 3. 1 row, 3 columns.
Okay.
How about the next one? How many rows does it have?
2.
3 rows.
What? Oh, 3.
Because rows go this way.
Alright.
How many columns does it have? 2. So this is a
3 by 2.
3 by 2 matrix. Now you're not going to go 3 times 2 and say, oh, it's a 6. Okay? We have to actually separate the rows by the columns because that tells us what shape to create. Okay? Now the other thing, if you're struggling with keeping rows and columns straight, think about old-time colonial homes. What do they have out front? They have columns that go floor to ceiling, right?
They do.
Yes.
They do.
Think White House.
White House?
Oh.
You,
The White House.
the White House?
The like big columns in front of the White House. Columns go floor to ceiling. So they're
Sounds like you're saying like you didn't know what the White House was.
no, but he was like White House?
The inflection in your voice kind of told me that might not be a good thing, so.
Is that gonna be in the video?
Yes.
Hey, shout out to the video.
All right, go ahead and try 3 and 4.
Nine. Two by two?
Never done, right? No. Doing the unit?
Day 1 of the unit.
Why
The
does it have to
syllabus,
be
you know
on?
this thing is 6 days long?
So are we ever gonna put this in the calculator? Yes. Ms. Schwartz already said it's a way to do it in the calculator.
Oh, there are ways to do it in the calculator, I
not
just
gonna
don't
work?
think I'm gonna show you.
You're not gonna show us.
That's the easiest way to do it.
Ooh, hard.
That's why.
Is this gonna be on
What
the-
do we deserve
I
this?
mean, I'm gonna need
I
it.
don't know. You can use your calculator on it.
Hold
I
on.
You
just
figured
don't-
out how to do it in a calculator, you can use it.
Khan Academy.
Here we
I'm
go.
going to Ms. Schwartz.
Time to figure it out. You have to remember, Schwartz and I are friends.
It's a different Ms. Schwartz I was talking about, you know.
If you tell me
Yeah,
it's
it's
Right.
Is it this button that says Matrix?
There's a button.
I found it.
All right, guys, what's the order for number 3?
One by one.
Two by.
Oh! Oh my God! Yo, yo, Ms. G, I just knew I was right. Zay.
How about number 4?
Two by
2 by 2. Now,
Zay.
She said it was
this is
something
an
else.
example of a square matrix because the number of rows matches the number of columns. This is an example of a column matrix because it only has, or sorry, this is an example, yes, it's an example of a column matrix because it only has 1 column. It's just one
So
single
would
row.
one be a row matrix?
Yes, first
So
one.
1 is a row matrix because it's 1 row. If you wanted to, yeah. you could do 1. So this is a row matrix because it's 1 single row. That's a column matrix because it's 1 column. And that's a square matrix because the columns and the rows match each other. We've got a 2 by 2. All right, so we're going to start with something called scalar multiplication. Now, we call this scalar multiplication and not just matrix multiplication because scalar multiplication means you're going to take an entire matrix and multiply it by a single number. Matrix multiplication says we're multiplying 2 matrices together, and we're not ready for that. Okay?
That's over.
It won't be out of your league next week, but it's out of our league right now.
Are we
Okay.
gonna do that next week?
Yes.
That's crazy.
All right. So let's say you have this matrix A. What's the dimension here?
2 by 3.
It's a 2 by 3 matrix. Okay. And let's say I rewrite this as 6A. So that means I'm going to multiply the whole matrix by 6.
Okay.
What that means is you take that 6 and multiply every single number in the matrix by 6.
Yeah.
And that's your answer.
Not bad.
So 6 times 2 is
Where'd
12,
you get
6 times
6
0
from?
is 0. It was just, it's an example of what, if you were to multiply everything by 6. then that's what you would get. Alright? So for the first one, what am I asking you to do?
Multiply every number by -5.
Multiply every single number by -5. So what is my 1-1 entry? So first row, first column. It's gonna be
15,
first row, second,
0,
second row, first,
-20, yeah.
and second row, second. That's your answer. Please make sure you put the brackets back around it, otherwise you just put numbers in a box-ish formation. It's not a matrix if you don't actually put the brackets back on it. Does that make sense?
Oh.
Next one's a little different because I got a variable involved. But what's 2u times 7u?
14 squared.
14u squared. 2u times 3w squared.
6W squared.
18.
That's quattro.
I would put the u in front just because u comes before w in the alphabet.
Okay.
Can I do it the other way though?
10.
I don't
We
like that.
typically rate alphabetically.
That makes me sad. It looks better.
All right,
with the
2u times 5u.
10 squared.
10u squared, and then
Uh-oh, you on camera now.
10 you. You want to?
Alright, gotta take your foot off. And then 2u times 5 is 10u. And so that would be your answer to that scalar multiplication. Try the last one on your own.
Okay.
I'm gonna use this little button that says
Whatever.
16. Negative.
It's not.
It is, bro.
I said 4 times 3 minutes.
Oh, that's what he said. I
Guys,
thought he said that.
you're too loud.
Ms. G.
No,
Ms. G.
no,
You got actual? Never mind.
she's not here.
Dang, Miss G, you probably needed a recorder like a different class.
Yeah, bro. Because I just put it out from dumpster. I put it negative 28 for 4 times negative 4.
It's because you did 7 times negative 4. I just
Bro, I
Bro,
know,
yeah.
7's the
you know
question
if it's
number.
still recording.
I don't care, bro. Hey, bro, they go through.
Alright guys, how about number 7? You don't get negative 28 because I'm not doing 7 times the whole thing, I'm doing 4 times the whole thing.
Yeah.
But 4 times negative 4 is negative
Negative
16,
16.
4 times 3 is 12, and 4 times negative 5 is negative 1. Alright, do you guys see how you don't change the shape of the matrix when you use scalar multiplication? You just
Yes.
multiply each number, leave it the same shape? Are we okay with scalar multiplication? Is it pretty easy?
Yes, it
Are these IXLs going to kill you today?
Not really.
I hope
Because
not.
this is it. Like,
No, because they're the back, Ms. G.
yes, but the back is adding and subtracting.
That's to get home.
Hey, you already see I can't multiply.
You're done, Miss Gretchen. Figured it out. I cracked the matrix. Alright, well then I guess I'm going to have to make things non-calculator.
No.
Come on, Maddie.
I'm just saying.
Nice try, Maddie.
Alright, Hubert, stop it and then restart it.